If I told you your old phone has gold inside it, you'd probably laugh and say, yeah, right. But here's the wild part. It's absolutely true. Every smartphone, every laptop, every TV remote you've ever owned hides tiny amounts of gold, silver, copper, and even palladium. They're like secret treasures, buried inside the circuitry that makes our modern world tick. Now, it's not much, about 0.034 grams of gold per phone. That's smaller than a flake of glitter. But here's where it gets crazy. If you collected 1 million discarded phones, you could get more than 34 kilograms of gold out of them. That's worth over $2 million. So yes, your junk drawer could literally be a gold mine. Welcome to the fascinating world of e-waste recycling, where mountains of old electronics are reborn as raw materials. And sometimes pure gold. It's part science, part treasure hunt, and part sustainability miracle. Before we melt anything, we start with the hunt. But this isn't the Wild West. There are no pickaxes, no river pans. Today's gold rush happens in warehouses and recycling centers around the world. Picture this: endless bins filled with tangled cords, cracked screens, keyboards missing keys, old monitors, and circuit boards with gold-lined fingers. To most people, it's junk. To recyclers, it's what they call urban ore, the modern-day equivalent of mining a mountain, except this one's made of plastic, silicon, and forgotten gadgets. And here's a fun fact. A ton of e-waste contains up to 100 times more gold than a ton of natural ore from a traditional gold mine. So yeah, you could dig through rocks for months, or just raid a few office basements. Once all that e-waste is collected, it's taken to massive recycling facilities, some the size of football fields, where the real work begins. Inside, machines hum, conveyor belts rattle, and the faint metallic scent of old tech fills the air. It's the start of the journey from trash to treasure. When the trucks roll in, the first step is sorting. It looks like organized chaos. Piles of electronics getting separated by type, old desktop towers on one side, phones and tablets on another, cables coiled like snakes in another pile. Then the machines step in. Robotic arms, magnets, air jets, all working together like a futuristic orchestra. Magnets pull out the steel. Air streams blow away the lighter plastics. What's left behind are the heavy hitters, the parts rich with metal. But the real treasure? It's hidden inside the circuit boards, those flat green sheets filled with tiny gold connectors, chips, and pathways. Before the gold can be extracted, the dangerous stuff has to go. Batteries, for example, are carefully removed because they can explode under heat. Same with capacitors and fluorescent screens. They're all isolated and sent for safe disposal. The goal is simple: strip it down to the good stuff. Every cable, every microchip, every golden connector is carefully set aside for what comes next. Think of it like unwrapping a really stubborn Christmas gift, except instead of wrapping paper, it's layers of plastic and aluminum shielding. And instead of a toy inside, it's gold. Next is the dismantling stage, where we literally unbuild technology. Imagine taking apart a computer piece by piece, but with scientific precision. Workers in anti-static gloves sit at benches armed with drills, suction arms, and even screwdrivers. They're not destroying, they're disassembling. Carefully removing glass screens, cooling fans, motors, and memory cards until only the metallic skeleton remains. Each component has its own destiny. Plastics go one way, copper wires another. But the motherboards and connectors, those shimmering green panels speckled with gold, are the crown jewels. You could almost say it's the reverse of a factory assembly line. Instead of building the next iPhone, they're politely unmaking the last one. It's tedious, detailed, and strangely satisfying. Because once the disassembly is done, you're left with the purest pieces ready to be shredded and smelted down into something entirely new. Now, things get loud. Massive shredders, some as big as small cars, chew through circuit boards and metal casings like it's breakfast. The noise is like thunder. Sparks fly. In seconds, an entire computer tower is reduced to confetti. But this destruction has a purpose. By grinding everything down into smaller fragments, recyclers make it easier to separate the valuable materials from the waste. Magnets swing over the debris to pull out any remaining steel. Eddy current separators use electromagnetic fields to fling away any non-ferrous metals like aluminum and copper. Lighter bits like plastics, dust, and glass are blown out of the mix with air jets, leaving behind a dense, shimmering pile of metal particles. Up close, it looks like chaos, but in reality, this is precision work. Every piece, no matter how small, is being sorted for its metallic makeup. And buried in that metallic confetti? Tiny golden fragments, the first glimmer of treasure. So yes, we've officially reached the point where we're literally turning garbage into glitter. Once all the sorting is done, the real magic begins. Welcome to the smelting stage, where chemistry and fire take over. The shredded metal mix is fed into enormous furnaces that roar at over 1200 degrees Celsius, hotter than molten lava. Inside, the metals lose their shape, their color, their identity. Copper, gold, silver, and other metals melt into one glowing liquid mass, while impurities rise to the surface as dark, glassy slag. It's mesmerizing, like watching the Earth's core in a factory setting. The molten mixture is poured into thick graphite molds and cooled into what are called anodes, dull, rough slabs of mixed metal that hold the potential for something extraordinary. Hidden inside each slab is real gold, waiting to be separated from everything else. And here's where modern recycling turns into a science experiment on an epic scale. Those slabs are submerged in chemical baths filled with a special solution that conducts electricity. Then, electric currents are passed through the liquid. Over time, the base metals, copper, nickel, and zinc, dissolve into the solution. The precious ones like gold and silver resist. They cling stubbornly, forming a fine metallic dust at the bottom of the tank. And that dust? That's the gold. Each speck once sat inside a phone, a laptop, maybe even the device you're watching this video on right now. It's an incredible full circle moment, technology being reborn at the atomic level, from broken circuits to a handful of shimmering dust. But the story isn't over yet, because that dust still needs to be purified, refined until it becomes solid, radiant, and 99.99% pure. That part is where the real alchemy begins. So we've got our golden dust, tiny, almost invisible flakes that look more like sand than treasure. But now it's time to turn that dull powder into something solid, shiny, and pure. And here's where things get both sciencey and magical. Inside the refining lab, it's not some medieval goldsmith's workshop. It looks more like a mix between a chemistry lab and a sci-fi movie set. White coats, safety goggles, ventilation hoods humming in the background. And in the middle of it all, tubs, beakers, and tanks filled with brightly colored liquids, each one bubbling like a potion that could make or break the gold. This is the chemical refining stage, where the gold gets separated from everything else still clinging to it. The copper, the nickel, the tin, the mystery metals that came along for the ride. The process usually starts with a solution called aqua regia, which is Latin for royal water. It's a mix of hydrochloric acid and nitric acid, and it's one of the only substances on Earth strong enough to dissolve gold. That's right, the king of metals actually bows to this liquid fire. So the gold dust is poured into a large glass beaker, and the aqua regia is slowly added. Immediately, it starts fizzing, releasing orange vapors that look straight out of a villain's lair. The mixture turns from pale yellow to deep amber, the color of molten sunlight. What's happening is pure chemistry. The gold is dissolving into the liquid, forming a compound that can later be brought back as solid gold again. But here's the trick. You don't just leave it like that. Once it's all dissolved, technicians add special reducing agents, sometimes sodium metabisulfite or ferrous sulfate, which cause the gold to precipitate, or basically fall out of the solution again. The liquid clears up, and at the bottom of the tank, tiny brownish flakes start to appear. They don't look like much yet, more like cocoa powder than treasure, but that's pure gold, 99% clean. Once it's filtered out, washed and dried, that powder goes into a high-temperature furnace. Slowly, the brown turns red, then orange, and finally melts into a pool of shimmering liquid gold. It's hypnotic watching something that used to be junk electronics transform into this perfect glowing metal. The molten gold is poured into molds, small rectangular ones if it's being turned into bars, or tiny bead-shaped mold if it's meant for electronics. As it cools, the surface darkens slightly, forming a thin skin that cracks as it solidifies. When the mold is lifted, you see it, the unmistakable shine of gold. Each piece is then cleaned, weighed, stamped, and officially certified. It's not just recycled metal anymore. It's investment-grade bullion, good enough to go right back into global supply chains. And to think, a few hours ago, that gold was hiding inside an old phone you couldn't be bothered to charge anymore. But here's the thing, gold isn't the only prize in this process. Remember, every circuit board is like a tiny treasure chest, and gold is just one of the jewels inside. Those same acid baths and refining steps can also pull out silver, palladium, and platinum, each one used in everything from jewelry to catalytic converters, and even medical equipment. Copper and aluminum, which are recovered earlier in the shredding and sorting stages, are also melted and reused in new wiring and casings. So, in a single batch of e-waste, recyclers can recover a cocktail of valuable materials and none of it goes to waste. The leftover plastic and glass? They're cleaned, shredded, and often sent off to make insulation, construction materials, or even the casings for new devices. The only thing that doesn't make it out alive are the toxic byproducts, and even those are treated before disposal to prevent pollution. This is industrial recycling at its most advanced, a zero-waste goal that's equal parts engineering and environmentalism. Now, let's zoom out for a second. Imagine a warehouse filled with thousands of old computers, phones, and motherboards. Each one has only a tiny speck of gold inside, but when you process them in bulk, it adds up. A single ton of circuit boards can yield between 200 and 300 grams of gold. Compare that to traditional gold mining, where a ton of ore might only give you 5 grams. That's 40 to 60 times more efficient and without tearing up mountains, polluting rivers, or displacing communities. It's no wonder experts call e-waste recycling urban mining. We're no longer digging into the earth for resources. We're digging into our own trash. And here's the fun twist. Some of the world's biggest gold producers today aren't mines at all. They're recycling plants. Facilities in Japan, Belgium, and Sweden now refine more gold from electronics each year than some small-scale mines. One of the most fascinating examples? Japan's Tokyo Metal Project. Before the 2020 Olympics, Japan asked its citizens to donate their old phones and electronics. The goal? Extract enough gold, silver, and bronze to make all 5,000 Olympic medals. They did it, and every single medal handed out at those games came from recycled e-waste. Talk about turning trash into triumph. But let's not sugarcoat it. Recycling e-waste isn't easy. The process requires expensive equipment, strict safety measures, and highly trained staff. In countries without proper facilities, a lot of e-waste still ends up in informal scrapyards, where workers, sometimes even kids, burn wires or use crude acid baths to recover metal. It's cheap, but deadly. The fumes can cause respiratory diseases, and the runoff poisons soil and water. That's why responsible recycling is so important. It's not just about recovering gold. It's about protecting people and the planet. Thankfully, new technologies are changing the game. Scientists are developing eco-friendly methods that use bacteria, fungi, and organic compounds to extract gold without toxic chemicals. It's called bioleaching, and it's as weird as it sounds. Certain microbes actually eat the metals out of e-waste, leaving behind a clean, safe residue. It's slower, but infinitely cleaner, a sign that the future of recycling might be greener than ever. Now let's bring it home. The refined gold that comes out of these plants doesn't just sit in vaults. Most of it goes straight back into the tech industry to make the next generation of circuit boards, processors, and connectors. So, the gold inside your future phone might already have lived a few digital lives before. Think about that. That shiny ring on someone's finger might have once been part of a smartphone. The gold on a spacecraft's wiring could have started life as a laptop hinge. Even the next device you buy might carry atoms of gold that powered your old one. It's a literal cycle, technology being reborn again and again from its own remains. And the best part? We're only just scratching the surface. As recycling tech improves, we could recover not just gold, but rare earth elements, the stuff used in batteries, magnets, and chips. turning old gadgets into the raw materials of the future. It's a world where waste stops being the end of something and becomes the beginning of something new. So next time you toss an old phone into a drawer, maybe pause for a second. You're not just storing clutter, you're holding a tiny vault of hidden wealth. A bit of copper, a sprinkle of silver, a trace of gold that's already seen more transformations than most of us will in a lifetime. It's history, value, and sustainability all packed into a single circuit board. Who knew the real treasure was hiding inside our trash all along? So, the next time someone says, "There's gold in your phone," don't laugh. Tell them they're absolutely right. And if you found this journey from junk to gold fascinating, give this video a thumbs up. It helps the story reach more curious minds. Want to see what happens next? Because if you think melting down phones is cool, wait till you see what happens when old batteries get recycled. Let's just say it's one of the few times explosions are a good thing. Subscribe, stay curious, and remember, sometimes the most valuable things on Earth are already in your hands.